In this problem, it says that we're given a regular hexagon, and two arcs of circles are drawn from opposite vertices of the side as a radius. So this side is the radius of this arc. Same thing here. Now it says that this length is 12, so that means 12 is the radius of this arc, but it's also all the side lengths of this hexagon. We want to determine the shaded area. So what we need to do is we need to first find the area of this regular hexagon, and then we need to subtract out the arcs. Now they gave us that each side has a length of 12. Now the way to think about a hexagon is really just 6 equilateral triangles mashed together. And in an equilateral triangle, all the angles are 60 degrees. And so what you can do is you can cut that in half. And so what you end up with is two 30, 60, 90 right triangles within one of these equilateral triangles. And so this length is 6 and this length is 6. And so this height right here is 6 square root of 3. So if we can find the area of this one triangle, then we can find the area of all 6 combined. So the area of the triangle is 1/2 the base. The base here is 12 times the height, which is 6 radical 3, times however many triangles there are. In this case, there are 6. All right. Now the radical we can't simplify, so we're going to have to leave the radical right there as is. But it's 6 times 12 times 6 times 12 times 1/2. So that's 6 times 6 times 6, which is 216 square root of 3. Now that's the first part, but now we have to say, well, what about those arcs? Each of those arcs has a radius of 12. And the key thing is, what is this angle? This angle here is 120. This angle is 120. Now the way you know that is, going back to here, we said that all of these are equilateral triangles. So this is a 60-degree angle, and so is that. So altogether, that makes up 120 degrees. So that's how we know this. So these are just parts of a circle that we want to find the area of. So this is 120 degrees, this is 120 degrees. In total, that's 240. Now a whole circle, is 360 degrees. So if we mash this together, we're talking about 2/3 of a circle if we combine them. So the area formula for a circle is pi r squared. So we have pi times 12 squared times 2/3, because we're only talking about 2/3 of a circle. So then we got 144 when we square the 12. And then when we multiply that by 2/3, we're going to get, let's be sure, yep, we get 96 pi. And so the question asked for the exact area. So we take the area exactly of the entire hexagon, and then we subtract away the area of the arcs. So our final area is 216 radical 3 minus 96 pi. And there's our answer, and we're done.